Bismillahirrahmanirrahim. Today I am going to discuss chemical properties of inorganic materials. So in previous lecture I told you the difference between inorganic material and inorganic compounds. But in this lecture I will discuss the effect of surrounding chemical environment on structure and function as well as activity of the inorganic materials. Generally, there are four main classes of inorganic material including ceramics, metals, glasses, stones, rocks or their derivatives. So first of all, let's see the effect of environment like acid rain, moisture, other environmental effect, temperature changes are the effectiveness, strength of sunlight. These parameters may interact with the structure of these inorganic materials and as a result structural deformation or activity may be affected. Usually inorganic materials are not flammable, but under flame or fire their structural deformation may take place. They may interact with flame or fire, so their activity is affected. Okay, few of the inorganic materials, they may undergo oxidation in the presence of air. So for example, aluminium, in the presence of air it may undergo oxidation to form aluminium oxide as a thin film over the metal which protect it from further corrosion. So few of the metals they start corrosion in the presence of moist air. So many of the inorganic material they interact with the acids, few with alkali, salt solution and other chemicals. Okay, there are various methods to describe the action of these materials with the acid or other chemicals. Well, in this lecture I will discuss the effect of chemicals or water on metals or corrosion of metals. So what is corrosion? Chemical decay of metal is called as corrosion. Pure metals are less likely to undergo corrosion. What? Well, how corrosion is induced? When two metals become in contact with water, then the electrochemical cell is formed which result in the decay of one metal. For example, copper and aluminium alloy. When they come in contact with rain or moisture, then what happened? That for example, rain gives water and water covers the surface of both the metals, and water by auto-dissociation, auto-ionization produces H ion and OH ion. Carbon dioxide in the atmosphere may react with water to form carbonic acid which undergo dissociation to form hydrogen ion and bicarbonate ion. All these ion covers the surface of both metals. Spontaneous electrochemical cell is established. In this way, one metal acts as anode and other act as cathode. Why the aluminium is acting as anode, I will tell you in electrochemical series. Well, aluminium acting as anode, and we have studied that the oxidation takes place at anode. So hydroxide ions as negative ion, these are attracted towards the anode, towards aluminium. Aluminium undergo spontaneous oxidation and produces electron. Then this tri-positive ion combine with hydroxide to form gelatinous aluminium hydroxide. Add aluminium is detached from the metal, so chemical decay or corrosion is started. These electrons produces as a result of oxidation moves towards cathode, and you know that the positive ions are attracted toward cathode, so the hydrogen ions gain these electrons to form hydrogen gas. In this way, one metal undergo corrosion while other metal remain the same. Okay, as most of the mega structures we use iron, so iron can be protected from the corrosion either by anode coating or by cathode coating. So what is anode coating? When we cover the surface of iron with zinc then this is called as anode coating. Why we called it anode coating, I will tell you later. And when we cover the surface of iron with stainless or tin, then this is called as cathode coating. Now, what is anode coating? When iron is covered with zinc. Okay, in this structure, you see that the iron is totally covered with the zinc. Okay, as long the zinc is present around iron, there will be no corrosion. When this coating is ruptured, then water ions, hydrogen or hydroxide ions may penetrate and may in contact with both the metals. Now, as I told you here, spontaneous electrolytic cell was produced. Here also electrolytic cell will be produced. So here iron will act as cathode while the zinc will act as anode. So zinc will be corroded, as you see there aluminium which was acting as anode undergo corrosion. So oxidation of zinc takes place. There will be no corrosion of iron. As zinc is going undergo corrosion, so zinc is sacrificing, so this corrosion is called as sacrificial corrosion. Okay, in this iron act as cathode, while if we cover the surface of iron with tin stainless, when electrochemical cell is formed, then iron it act as anode and the tin act as cathode. Here iron will be corroded as it is acting as anode. So these two coatings, this coating seems to be temporary, while this coating, zinc coating, this will be more effective. So how the corrosion is protected, how the materials are protected from the chemicals or their chemical environment or from corrosion. Usually we use paint, oil or greases. Well, there are few modern technologies which are which we use nowadays to protect the material or metal from being corroded. So organic thin films may be used like acrylic material, epoxy resin, polyamide or PVC. These are used on various materials to protect them from environmental changes, environmental actions. So few of the hybrid coatings including organic and inorganic molecules. For example, now in mobile phone technology or in other electronic devices, we are using scratchless glasses. So the coating used on those glasses is hybrid coating. So inorganic additives, inorganic elements are used, inorganic compounds are used even to protect the metal to being corroded. For example, stainless steel, it is made with nickel, chromium, copper and manganese as an additives which protect them, protect the iron present in them from corrosion. Most advanced technology we are using to protect the inorganic material, these are nano coatings or nano coverings. We cover the surface of the metal or other inorganic material with nanoparticles which protect them from other chemicals or environmental effects. So nano coating provide durability, thermal stability or surface optical properties, and these are usually inexpensive. They enhance the physiochemical characteristic of the material. These produce least toxicity to and long life activity to the material. Well, these coatings are not long lasting. They may affect from the chemical, these may affect from the environmental actions such as swelling, oxidation, dissolution, color change. Well, their presence over the material may protect the material for a long time. Nano covers may be applied physically or chemically, and which techniques we can use: chemical vapors deposition, physical vapor deposition, thermal, plasma spray, sol gel. We will discuss all these techniques in the coming lectures. So which material we can use to protect the material? Maybe carbides, nitrides, borides, metal oxide. Usually these oxides are of transition metals. So these materials can be used as a coating material. So this is all about chemical properties of inorganic material and their protection from the surrounding chemicals are from the environmental changes or from the environmental effects. Thank you very much.